Good morning, students. In the last class, we discussed about the Bohr's atom model. From that, we find the relation of the radius of the n orbit. That is radius of the nth orbit in an atom. That is Rn is equals to epsilon naught n square h square divided by pi m z e square. That is, in any atom, the radius of the nth orbit is given by the Bohr's. That is, Rn is the radius of the nth orbit. That is equals to epsilon naught n square h square divided by pi m z e square. Right. So for hydrogen atom, the atomic number of the hydrogen is 1. That is, the Z value is 1, and also it has 1 electron. That is, the N value is 1. That is, Z is equals to 1 and N is equals to 1. Right? So we get R1, that is equals to epsilon naught h square divided by pi m, and we call this radius as Bohr's radius, and they denote it by A naught, right? So this one is the Bohr's radius, right? So the Bohr's radius A naught is equals to epsilon naught h square divided by pi m e square, right? So for Bohr's radius, we need to substitute the value z is equals to 1 and the value n is equals to 1. Then we getting the Bohr's radius A naught is equals to epsilon naught h square divided by pi m e square. As all these values are constant, this epsilon naught is constant, where h is the Planck's constant and pi is also constant, mass of the electron is constant and charge of the electron is constant. Now if we substitute all these values, then we get the standard value of the Bohr's radius A naught, that is equals to 5.29 into 10 to the power of minus 10 meters. Right? As all these values are constant, epsilon naught value is constant, h value is constant, pi m e. So all these values are constant. So we can substitute the values and simplify. Then we get the value, that is Bohr's radius of the hydrogen atom, that is 5.29 into 10 to the power of minus 10 meters. Right? So this is about the Bohr's radius, right? Here, if we consider this one as the positive nucleus, so around the nucleus we have several of the electrons which are revolving around that nucleus. So that one is the positive means. In hydrogen atom, the first orbit is the Bohr's orbit or Bohr's radius. Right? For hydrogen atom, here the n value is 1. So this is n value is 1, n is 2, and here n is 3. Right? So when n is equals to 1, so this radius we call as Bohr's radius and it is denoted by n. Right? So and we have the value for the hydrogen on power of minus 10 meter. So this is all about the radius of the nth orbit and also the Bohr's radius. So if they ask for the Bohr's radius, then we need to substitute Z value and N value. We get this one is the standard relation for the Bohr's radius, right? So next, for the N orbit, so if we consider this one as the N orbit, then this distance is what? That is Rn. Here we have the electron means it has velocity V is the velocity of the electron and electron has mass m and charge e. Right? So it is at a distance that is r n. For the n orbit, if we find the velocity of the electron in the n orbit, as already we derive the relation, that is by using the Bohr's postulate, the electron is revolving around the nucleus in a circular stable orbit and that will not radiate any energy, right? So that is from the first Bohr's postulate. If we write the relation, that is centripetal force. Centripetal force is equals to the electrostatic force between nucleus and electron, right? So this is from the first postulate, that is the electron is revolving around the nucleus. So for the centripetal force that is exerted by the electron is equals to 1 divided by 4 pi epsilon naught into Ze into E divided by Rn square. Atomic number, right? So this we can write. So here Rn get cancelled, then mv square Rn, that is equals to Ze square divided by 4 pi epsilon. Similarly, as we derived in the last class, right? So this is from the first Bohr's postulate. Next, the angular momentum relation, that is we can write from the second postulate mvrn, that is equals to nh divided by 2 pi, right? Equals to nh by 2 pi. This is from the Bohr's second postulate. So we call this one as the second equation. Right? Now if we divide, we need velocity of the electron, right? So we need the velocity of the electron which is revolving around the nth orbit. Then if we divide equation 1 by 2 or equation 2 by 1. So if we divide the equation 1 by 2, then divide equation 1 by 2. So here we have LHS terms mv square Rn divided by mv Rn, right? That is equals to the RHS terms Ze square divided by 4 pi epsilon naught. So whole divided by nh divided by 2 pi, right? So dividing LHS terms and RHS terms. So this is the first equation from the first postulate, the second equation from the second postulate, right? So here mass of the electron, radius get cancelled. So here 1v get cancelled. So remaining is v, right? So v, that is equals to, so if it shifts to the numerators, then Ze square divided by nh, right? So now if we observe here 2 pi, here we have pi get cancelled, so 2 to the 4, right? So from this v is equals to, so we are finding the velocity in the nth orbit, then we can write Vn, that is equals to Zt square divided by 2 epsilon naught n h, right? So this is the velocity of the electron which is revolving around the nucleus in the n orbit, right? So that's why hydrogen atom Vn is equals to, that is Z value becomes 1 and n value becomes 1, right? So V is equals to E square divided by 2 epsilon naught h. So that gives the velocity of the electron which is revolving in the hydrogen atom. That is V is equals to E square. Z value is 1, N value is 1. So the remaining is V is equals to E square divided by 2 epsilon naught h for the hydrogen atom. Right? So this is the relation for the velocity of the electron in an atom, right? So now if we observe this relation Vn, as Z is constant, E is constant for a given atom, Z is constant, E is constant, 2 epsilon naught is also a constant, H value is also constant. Then we can write Vn is inversely proportional to 1 by n. The only varying factor is, from this we can write Vn is inversely proportional to 1 by n, where n is the number of the orbits which are varying. That is, value n varies from 1 to 3, like that, right? So if we write here the value of n is equals to 1, here we have n is equals to 2. So if I draw one more orbit, so this becomes n is equals to 3, right? So from this relation we can say, as the number of orbits, right? So as the number of orbits increases here, the order of the orbits changes. Here we have the initial 1, after that we have 2, 3, right? So the n value changes, then automatically velocity, that is n value increases. So observe here 1, 2, 3, 4, 5, like that, right? So if we have any atom has more than one orbit, then we can naming that as n is equals to 2, n is equals to 3, 4, 5, like that, right? So as n value increases, right, it is inversely proportional to that of the velocity. That means here the velocity of the electron in that orbit goes on decreasing, right? So here, as n is equals to 1, here we have the maximum velocity. As the electron which is revolving around in the second orbit, so here the velocity decreases, and further in the third orbit the electron velocity decreases. As the orbits increases, then the velocity goes on decreasing. The relation Vn is proportional to 1 by n. So that means we have the minimum velocity in the outer orbits. So we have the maximum velocity in the first orbit, right? So from this relation we can conclude, that is, as the n value increases, then automatically the velocity of the electron in that orbit goes on decreasing. That means this value decreasing, right? So this is about the velocity, and the velocity is inversely related with the number of the orbits, right? So as the number of orbits increases, that means in that orbit the velocity decreases. That is, Vn is inversely proportional to 1 by n, where n is the number of the orbit. So in the outer orbit we have lesser velocity, right? To understand this one, by this relation we can say, as As n increases, velocity of the electron in that orbit is decreases. That means the velocity in the outer orbit is less than velocity of, here also we will mention velocity of electron in the orbit. So this is by the relation Vn is inversely proportional to 1 by n. As n value increases, the Vn value goes on decreasing, because all other terms here we have the constant values, right? So we can conclude this statement by using this relation. As the outer orbits, in the outer orbits, the velocity of the electron goes on decreasing as compared to that of the inner orbits, right? So this is about the velocity of the electron which is revolving around the nucleus, right? So if we need to find the velocity of the electron in the second orbit, just we need to substitute n value 2, right? If we find for 3, then we substitute n value 3. So all other remaining values are the constant values, then we get the velocity of the electron, right? So this is about the velocity. So and the main important is energy of the electron. So as already states that Bohr just modified the theory which was given by the Rutherford, derived the relation, that is energy of the atom that is total energy of the atom in the Rutherford theory, right? So he made just a modification to that theory. Energy of an atom, right? So as already know, the total energy E is equals to minus 1 divided by the Rutherford, right? So by using the summation, that is sum of the kinetic energy and potential energy, we are getting the total energy. Yes. So this relation is given by the Rutherford. So he made just the modification in that energy is, so here they given the radius or by the radius which we calculated, that is the electron which is revolving around in the nth orbit, that is the value of Rn, that is the radius of the electron which is revolving around in the nth orbit, right? So as already we derived the relation, so directly we can substitute the value of Rn, right? So the value of Rn is epsilon naught n square h square divided by pi m z e square, right? So this is the radius which we calculated in the last class. Now just we need to substitute the value of R in place, that is the value of Rn. Then we use the energy which was proposed by the Niels Bohr, right? So now substitute this value of R naught n square h square divided by pi m z e square, right? So now this one is in the numerator, pi get cancels, so the remaining here E is equals to, so as it goes to the numerator, m z, here we have e square and here also we have e square, then it becomes e to the power of 4, right? mz e to the power of 4. So here we have minus divided by 8 epsilon naught into epsilon naught, that is 8 epsilon naught square n square h square. Right? So this is the energy of the atom. Right? For the hydrogen, for hydrogen, for hydrogen, Z value is equals to 1 and N value is equals to 1, then the energy of the hydrogen atom E is equals to minus m e to the power of 4 divided by 8 epsilon naught square h square. Right? So this one is the relation of the energy. Right? So we need to remember this equation, either the Rn value, this relation and this relation. So in 2018 they asked this relation for 1 mark. So directly we need to write the expression for the energy of the atom. Right? So if they ask for the energy of the atom by using the Bosch postulate, means we need to write E is equals to minus m z e to the power of 4 divided by 8 epsilon naught square n square h square, and we need to explain what is m, mass of the electron, z is the atomic number of the atom, E is the charge of the electron, and n is the orbit, and h is the Planck's constant. Right? So we need to remember these relations, either velocity, radius, because they directly ask for 1 marks. Right? So in 2018 they asked this one for only for 1 marks. Right? So if they ask for the hydrogen atom, just 1, then here we get the energy of the hydrogen atom. Right? So as if we observe here, all these values are constant. Mass of the electron is constant, charge of the electron is constant, epsilon naught is constant, and h is the Planck's constant. So if we substitute all these values, then we get the value. So here this is the energy of the E is equals to, that is minus 2.18 into 10 to the power minus 18 divided by n square joule. Right? So here we have n square. So this is for the energy of the atom, because I will substitute here only. Right? So all these values are constant. So energy is inversely related with the n square. Then we get En. So this one is En. So this is not for the hydrogen, just En. General formula En is equals to minus 2.18 into 10 to the power of minus 18 divided by n square into n square, that is joule. So as in atomic physics and in nuclear physics we denote the energy in terms of electron volt, then this relation is divided with the 1 electron, that is 1.6 into 10 to the power of minus 19, then we get energy in the form of electron volt, that is minus 2.18 into 10 to the power of minus 18 divided by 1.6 into 10 to the power of minus 19. Then we get the relation minus 13.6 divided by n square electron volt. So this is the energy of an atom in the n orbit. Right? So this is the energy of the atom in the nth orbit, where n represents the orbit. So if we substitute 1, then we get E1. If we substitute 2, we get E2. Right? So by this value is constant, then we relate this equation En is inversely proportional to 1 by n square. That means, observe here, this is the negative value energy. So this negative symbol represents, means what? this electron is bounded by this nucleus, right? So here minus 13.6 is lesser value. Why? Because if you observe, so 0, here it is -1, -2, -3. So observe here, that is -13. So if you observe here, which one is greater value means -1 is greater than that of the -13, because we have the negative value here. So in the negative value, -1 is greater than -13, right? So that means this -13 value is lesser value, right? So this -13 is lesser value, right? So keep in mind that this value is lesser value. So if we substitute n is equals to 1, then this value becomes 1 square. 13.6 divided by 1 square, we get E1 is equals to minus 13.6. So then the energy of the first orbit is 13 minus 13.6 electron volt, right? So now if we substitute n value is equals to 2, so 2 square is 4, that is 13.6 divided by 4, then around we get 4 3 are 1, 3.4, that is minus 3.4. So in the second orbit we get minus 3.4 electron volt, right? So if we compare these two values, so this value is greater value than this one, right? So that means as orbit increasing, so the energy of the atom increases. That means in the first orbit, the atom energy is very less. As the orbit value increases, that means this one is the second, n value is 2, then we get the value minus 3.4. So don't compare only the magnitude values, that is 3.4 is smaller than 3.6, because here we have the symbol, negative symbol. We need to concentrate on this negative symbol. That means this value minus 3.4 is bigger than that of the minus 13.6 electron volt. That means in the second orbit we have greater energy compared to that of the first orbit, right? So understand this one. So if we substitute n is equals to 3 to this relation, then we get 3 square, that is 9. 13.6 divided by 9, we are getting approximately minus 1.51 electron volt, right? So as further we given n is equals to 4, n is equals to 5, then we get the values for a certain orbit. The value E is greater than 0 or E is equals to 0. That means this negative value crosses the bounded by this atom, right? So if this energy value is positive means, so this electron is not bonded with this nucleus. That means it is separated from this nucleus. That means this electron is away from the nucleus. Then these atoms get ionized, right? So only we have the positive charge in the atom, but we don't have any electron. That means this atom get ionized when after it crosses the value 0, right? This value goes on decreasing as the orbit values goes on increasing. For a particular orbit number, for example, if n is equals to 6, right? So now if you substitute here 6 square, 36, that is 30.6 divided by 36, then this value is almost nearer to that of the 0, that is the positive value. Then so here the electron is free from this atom, right? So this electron is free from this atom. That means this atom is completely ionized, only the positive, right? So this atom is only positive value, right? So that's why the negative sign is important, right? So here in the lower orbits the energy is less, as the number of orbits increases, in the outer orbits the energy is more. So from this we can say that, right? So if we say here the 13 number is greater than 3, that becomes wrong. This energy is more, will be wrong, because this energy is less compared to that of the outer orbits. So if you compare for a certain orbit, the value becomes 1. If you compare 1 with 13, then 1 is greater than that of 13. That means in the outer orbit, the energy is more than that of the first orbit, right? So this is the energy relation, right? So directly we can write En is equals to minus 13.6 divided by n square electron volt, right? So this is in the form of joules. So we need to convert joules into electron volt, means we need to divide this one with 1 electron. That means 1.6 into 10 to the power of minus 19. Then only we get the electron the atom in electron volt, right? So electron volt is the unit, right? So this is about the energy of an atom. So we need to remember these formulas, right? So this one is the radius, this one is for the energy, and in the last we discussed about the velocity, right? So this is about the energy, right? So by using this one we can discuss the energy levels of the atom, right? Energy levels. Energy levels. So as already says, the energy of the atom is least when the electron is revolving in the closest orbit, right? So if you observe here, which one is the closest? So this orbit is the closest. So in this orbit, the energy is least. So from that one we can say energy of an atom is least. So least nothing but this value, larger negative value. That one we call as least energy. So in bracket we can write that one also. Largest negative value, right? When electron is revolving in the closest orbit, right? So from the energy relation, that is En is equals to minus 13.6 divided by n square electron volt. From this relation, we can say energy of an atom is least. That is, which one? Here is the nucleus. So closer to the nucleus, which orbit is there? So in that orbit, if the electron is revolving, means the energy of that atom is very less. So if the atom, that is, if the electron is revolving in the orbit second or third or fourth orbit, then the energy of the atom is more, right? So this one is the first point. That is, the energy of the atom is least when the electron is revolving around the nucleus in the closer orbit. So after this, we don't have any closer orbit. So the first orbit is here. So if the electron is revolving in the first orbit, then the energy of the atom is least, right? So as the values increases from 2, 3, right? Because this value is least for n is equals to 1, that is the closest orbit, right? So as the value of n goes on increasing, the energy values also increases, right? So the lowest state of this energy of the atom we call as the ground state, right? So if we draw the energy level, so this one is the lowest state, that is its value is minus 13.6 electron volt. So this one has the least energy. So this energy we call as ground state, right? So the lowest state of the atom, we call as the ground state, right? So after this, so this is for n is equals to 1, right? So next we have n is equals to 2, then we have the value that is here minus 3.4 electron volt. Minus 13.6 electron volts, here minus 3.4 electron volts, right? So this is for n is equals to 2. N is equals to 2, right? So next for n is equals to 3, we have here. So this one is for n is equals to 3. So that value is here we return minus 1.5 electron volt, right? So if we further orbit the electron remote, that is for n is equals to 4, then that value is minus 0.8 electron volt, right? So here 13.6 directly jumps to the energy minus 3.4, because as n values we substituting here we get these values, right? So for next orbits, for fifth we are getting almost close to one another, that is in between minus 0.8 to plus 0, right? So here that is 0 electron volt. So if you plot the axis units, so this gives the total energy E, right? So this is the representation of the total energy E. So this the lowest energy of the atom which is revolving in the first orbit, that the state is called the ground state of the atom, right? So the remaining all other states we call, so above this, above 0, here the electron is unbounded. So above 0 electron volt, the electron is unbounded in the atom. That means the atom is get ionized, right? So this first n is equals to 1, because the atom is in the ground state. The all other remaining states are called as excited states, right? So for n is equals to 2, this one is the first excited state. For n is equals to 3, that is the second excited state. For n is equal to 4, that is the third excited state, right? So these are the energy levels. So by using this relation, we can plot, right? So along y-axis, we taken the total energy. So along x-axis, we have represented the ground state, excited state, right? So as already said, the energy of the atom when the electron is revolving in the closest orbit, that is n is equals to 1, then that the state of the atom we call as the ground state, right? So if the electron is in the ground state, that is which is revolving in the first orbit, when this atom is collide with the electron, right? So when this atom is get collided with the electron, then the collided with the atom, then the electron which are present in this atom get excited. That means it gains the energy and it's excited to the next state. That is, its energy is when the electron is collides with the atom, the electron which is revolving around this atom gains the energy from this electron, and this electron gets shift to the excited state, right? So understand that one. Next, the minimum energy which is required by the atom to get excited from the ground state to here to the ionization state, then that energy we call as ionization energy. Right? So the minimum energy which is required by the atom to get escape, that is to get excited from the ground state to the unbounded state, that is electrons gains the energy and it jumps from the ground state to the unbound state, then that energy we call as ionization energy. So for ionization energy, here we have minus 13.6. This one is the value. So this minus 0, that is E. This one is the initial EI, and here we have EF. The minimum energy is 0 electron volt. That is E is equals to 0 minus of minus 13.6. Then we get 13.6 electron volt. Right? So for an atom to get excited from its ground state to its unbounded state, it needs the energy. How much energy it requires means 13.6 electron volt. That is EF minus EI, right? So this one is the initial state. So electron is present in this state, that is the ground state. When we given energy to this atom, so how much energy it will require? 13.6 volt. So when the electron or atom gains this much of energy, then this electron will shift out from this stage, that is unbounded stage. So that energy we call as ionization energy. So if how much energy is required to jump the electron from the ground stage to the first excited stage means, that is E energy is equals to, here we have EI. So this one we need to jump the electron from ground state to first excited state. That means here the value is EF and here we have the value EI. So EF value is minus 3.4 minus of minus 13.6. Then here we get 10.2 electron volt. Right? So this much of energy is needed for the atom to, that is electron, to shift from the ground state to first excited state. Right? So without energy, the atom will not jump from the ground state to the excited stage. Right? So from this we can say minimum energy is required to the atom to jump from the ground stage to the excited stage. So the minimum energy which is required from the atom to get out from the electron, that is get out from the atom, so that energy we call as ionization energy. So ionization energy of the hydrogen atom is 13.6 electron volt. So if the electron needs to jump from the ground stage to the first excited stage, then it needs 10.2 electron volt. Similarly, if we find between these two, right? So if it needs to jump from here to second excited stage, then minus 1.5 plus 13.6, then we get approximately 11.2 electron volt, right? So this is about the excitation stage, that is the lowest state we call as the ground state, and all other remaining states we call as the excited states, right? So ionization energy is the energy which needs or which gains the energy to escape out from the atom. So that energy we call as ionization energy, right? So as it jumps to the higher levels, after certain time it will come back to the ground state, right? So after certain time it will come back to the ground state. So at that time it will emit the radiations. So this is given by the Bohr's third hypothesis. So as the electron will transfer from higher energy state to the lower energy state, so then only it emits the radiation of energy, that is h nu, right? So as it jumps or it gets move on to the excited state, so it needs the energy, right? When after certain time the electron which is present in the excited state, it will jump to the ground state, while in that process it emits the radiation of the energy, that is h nu, right? So this is about the energy levels, and this is about the energy level in the hydrogen atom, because here we discuss the ionization energy, that is electron which is escapes out from the atom. For that purpose, it requires some energy, so that energy we call as ionization energy, right? So in the next class we will continue. Okay, thank you.